Welcome to the DIY Honda Garage channel. The DTC P2118 refers to a throttling actuator current range or performance problem in the Honda Pilot models from 2016 to 2022. This specific diagnostic trouble code, DTC, indicates an issue within the throttle actuator circuit that may affect the vehicle's power delivery and response when accelerating. The throttle body is the primary component involved in this issue, receiving signals from the powertrain control module, PCM, to regulate airflow based on accelerator input. The actuator is designed to adjust the throttle plate's position accurately, but any discrepancies can trigger the DTC P2118. Accurate diagnosis is essential because persisting issues can lead to reduced engine performance, risk of stalling, or increased emissions due to improper throttle control. The expert technician should ensure the vehicle's systems function well before conducting any repairs. The error description of DTC P2118 involves the throttle actuator, which is an integral component located within the throttle body assembly of the Honda Pilot. Its primary function is to manage the engine's airflow by adjusting the position of the throttle plate based on the driver's accelerator pedal input. When the actuator does not perform within the expected current range, it indicates a problem, thus triggering the DTC P2118. The throttle body is typically situated between the air intake and the engine's intake manifold, allowing it to directly influence the mixture of air and fuel. Correct operation of this actuator is crucial, as any malfunction can lead to erratic engine performance, increased fuel consumption, or stalling. This code can arise from either electrical issues, such as poor connections or damaged wires, or mechanical problems within the throttle body itself. The potential causes of DTC P2118 encompass a variety of electrical and mechanical issues. Poor electrical connections can occur at the throttle body connector or within the PCM, leading to inaccurate signal transmission and erratic actuator performance. Additionally, damaged wiring can lead to open circuits or short circuits in the wiring harness connected to the throttle body, impacting the actuator's functionality. Another significant factor is a faulty throttle body, which may include internal failures or wear that prevent it from operating correctly. Resistance or continuity issues in the wiring must be thoroughly inspected to ascertain the root of the problem. Each cause needs to be evaluated separately to confirm that the throttle actuator communicates effectively with the PCM. When DTC P2118 is present, various symptoms may manifest, affecting both the engine performance and driver experience. A noticeable symptom is engine performance issues, such as hesitation or stalling while driving due to inaccurate throttle response. Thus, the vehicle may exhibit reduced acceleration response, where pressing the accelerator pedal does not yield the expected speed increase. Additionally, drivers may observe the check engine light illuminated on the dashboard, prompting them to perform diagnostics. Other symptoms may encompass erratic engine idle or unintended acceleration changes, which may lead to a safety hazard if not addressed swiftly. Understanding these symptoms can guide the technician in quickly identifying the vehicle's issues linked with DTC P2118. The first step in troubleshooting DTC P2118 involves verifying the problem by putting the vehicle into the on mode, a state where the electrical systems are activated without starting the engine. It's critical to utilize the Honda Diagnostic System, HDS, to clear any existing DTCs, including P2118. After clearing the DTC, the technician will slowly press the accelerator pedal to the floor to check whether the DTC reappears. This step helps determine if the problem is consistent or intermittent. Upon pressing the accelerator, the PCM will assess input from the throttle body actuator to see if the DTC returns. Should P2118 show up again, it indicates a systematic failure that requires further investigation into the relevant circuits and components for repair. In the second troubleshooting step, the technician must first turn the vehicle to the off mode, ensuring that there is no power while performing electrical tests to prevent accidental shorts. Then, the SCS, Service Check Signal, line is jumped using the HDS, which allows the technician to bypass certain safety protocols and test circuits more directly. After waiting more than 1 minute, the next phase involves disconnecting the PCM connector B and the throttle body 6P connector to access the respective wiring. The technician will then check for continuity between the specified test points to determine if the SG5 wire, which connects the throttle body to the PCM, is intact. A successful continuity check indicates that the wire is functioning correctly. If not, it necessitates repairs to the SG5 wire to restore proper connection in the circuit. Step 3 of the troubleshooting process requires disconnecting the PCM connector C, which generally handles additional functions relating to throttle control and monitoring. With this disconnection, the continuity between test points 1 and 2 is checked specifically for the MTR1 and MTR2 lines. The idea behind this test is to ensure that both wires are intact and not creating a short. The condition will confirm whether there is a short present between the MTR1 line and MTR2 line through the throttle body circuit. If a short is detected, it is essential to repair the MTR1 wire immediately, as it could be causing the performance issues flagged by DTC P2118. If there is no continuity, further tests will be necessary to identify the problem areas in the circuit. In the fourth troubleshooting step, we focus on examining continuity between two specific terminals at the throttle body 6P connector. This involves checking if there is any electrical connection between both terminals that could imply a fault condition. The technician carries out this check while ensuring the vehicle is still in the off mode with the PCM and throttle body connectors disconnected. If there is continuity, it suggests a short circuit exists either in the MTR1 or the MTR2 wire, necessitating immediate repairs to ensure proper function of the throttle actuator. In the absence of continuity, it indicates that the wiring integrity is maintained, allowing the technician to move on to the next step of troubleshooting without further immediate repairs to these wire segments. The fifth step in the troubleshooting guide involves connecting two specific terminals at the throttle body 6P connector with a jumper wire, allowing for direct continuity checks. This is conducted while ensuring that the PCM connector B remains disconnected, isolating the necessary circuitry without interference. Once connected, the technician should check the continuity between specific test points on the PCM connector C. This test is critical as it confirms whether the MTR1 and MTR2 wires are functioning correctly without defects. Upon finding continuity, it suggests the wires are intact, assuring that we can proceed with the diagnosis confidently. Should this check reveal no continuity, it signifies that there could be an open circuit within either wire, necessitating repairs between the throttle body and the PCM. During the sixth step of the troubleshooting procedure, the technician must measure the resistance between two test points at the throttle body side, ensuring accurate assessment of the throttle's internal circuit. This occurs after removing the jumper wire used in the prior step. The expected resistance values should fall between approximately 1.2 ohms and 1.0 kilo-ohms. Anything outside this range can indicate an internal malfunction of the throttle actuator. Such a measurement is crucial, as it directly reflects on the actuator's performance capabilities. If the result falls within the normal limits, the technician can proceed to further system checks, but an abnormal reading implies that the throttle body needs to be replaced entirely to fix the performance problems associated with DTC P2118. The final troubleshooting step focuses on checking for continuity between two test points at the throttle body, specifically to identify any potential shorts to ground. This check is critical for assessing the integrity of the throttle actuator's internal circuit, permitting insight into whether electrical interference is affecting signal quality. If the resistance check shows continuity exists between the throttle body and body ground, this indicates a problematic short circuit that necessitates the replacement of the throttle body. Conversely, if no continuity is found, the technician is likely in the clear, allowing for an assessment of alternative issues. At this stage, substitution of a known good powertrain control module, PCM, or cross-reference with authorized service information related to DTCs could be the next logical steps. After completing all troubleshooting steps for DTC P2118 and performing the necessary repairs, it is vital to execute a final repair verification process. This entails confirming that all checks and repairs align with the standards set by the manufacturer. The technician will clear any fault codes from the PCM using the HDS to reset the vehicle systems. Following this, a test drive should be undertaken to ensure that the vehicle operates smoothly without triggering any fault codes. During this trial, the technician should monitor the vehicle's throttle response closely. The ultimate goal is to confirm that DTC P2118 does not reappear, reflecting successful resolution of the underlying issue. Though not specifically mentioned in the immediate diagnostic material, preventive maintenance plays a crucial role in averting future occurrences of DTC P2118. Regular inspections of the throttle body can help prevent the buildup of deposits that could impede its performance. Cleaning electrical connections periodically ensures that good conductivity is maintained, reducing the likelihood of electrical faults arising in the future. Additionally, consistently monitoring the engine's performance during routine services can lead to early identification of potential problems. Establishing and adhering to a regular maintenance schedule enhances the longevity and performance of the throttle control system, empowering drivers to avoid significant future repairs related to the DTC P2118. In conclusion, DTC P2118 is indicative of throttle actuator current range or performance problems, primarily affecting the throttle body's functioning. Proper diagnostic procedures are paramount to accurately identifying and rectifying the issue, incorporating systematic checks of electrical and mechanical components. Following each troubleshooting step carefully ensures that you rule out potential causes efficiently. Moreover, performing preventive maintenance can significantly enhance the overall reliability of the throttle control system in the Honda Pilot models from 2016 to 2022. Taking these measures into consideration not only resolves the immediate concerns, but also sets the groundwork for effective vehicle operation in the future. As a result, adherence to the steps outlined fosters a better understanding and management of any similar DTCs in the future. Please like and subscribe to the channel. See you next time.